Yes. So we're doing a different format. Reason being because I'm getting a lot of good reviews and about the CCNA initiative, YouTube videos and sessions, and they love it because we talk about theory and sometimes we hop in the lab and stuff like that. So, you know, so since I asked you guys that question in the Slack and you guys said you guys were ready for sorry about that. You guys are ready for routing. I wanted to jump in from a CCNA level and a little bit of a CCNP level and teach you guys certain things because I want it to make sense. And I have a strong feeling that you guys need details for it to make sense. Because if I go through these fundamentals, I don't care if you guys encounter a routing protocol, right? Maybe BTP, you guys would be like, oh, this doesn't scare me. I know the fundamentals. Okay. So let's go ahead and jump on it, right? And I'm starting from chapter 15 of volume 1, which is operating Cisco routers, but there's a couple of, excerpts from different books like the CCNP Encore that I touch on in this session, okay? So let's go ahead and get started, right? First things first, my favorite thing that exists, which is the OSI model and the TCP/IP networking stack. Take a quick glimpse, right? Where we're at now in our learning is layer 3 networking, IP addresses, source and destination, right? I want you guys to make that clear. In every one of my PowerPoint slides, I'm always going to have this as a reminder so you guys just know in your head, right? Because we're going to have troubleshooting exercises. I'm going to put you guys in the gulag so you guys understand that, right? But just keep this in mind so you can make it second nature, okay? So let's talk about IP routing, right? Sorry for not having words on the screen. I just like looking at pictures and then I can rather explain it, right? So if we look at this, right? If we talk about IP routing from like a fundamental standpoint, right? We know these two things. If a host is trying to reach a destination that's not within the network, it's going to send it to its nearest router. If a host is trying to reach a destination that lives on the network, it's going to send it locally. That's the host routing logic, right? Very simple. Okay, let's move on. Okay, take notes here. Okay, so this is exactly what I, at a high level in the last slide that I explained, but let's talk about it in depth. Read it word for word, right? The routing preference, right? Routing process preference, right? So if the destination is local, send directly, right? What does this mean, right? From a layer 2 standpoint, right? Find the destination's host MAC address, right? How would we do that from layer 3? We would need to do an ARP. We need to look at our ARP table, okay? So that host, right? Mykevia's, PC will go ahead and look at its ARP table and say, okay, maybe 192.168.2.5 maps to this MAC address. I can send this locally, right? Or I can just send an ARP to go ahead and find that out. Boom, I can go ahead and encapsulate the packet into a frame and send that via layer 2. Okay? Now, if we move to step 2, right? If the destination is not local, send it to that default gateway, right? We're still on Mykevia's PC, right? So she's, in the middle of July, maybe she's doing Christmas tree shopping. I don't know why. That's what we're going with, okay? What's going to happen is her host, whether it be a PC, VM, whatever, it's going to find the default gateway's MAC address. How is it going to do that? The same exact way from a layer 3 standpoint. It's going to do an ARP. It's going to see if it has an entry in its ARP table locally. If it doesn't, it's going to go ahead and do an ARP request. See if anybody responds to it, right, on the network, then boom. It's going to go ahead and get a response. Once it has it, same exact thing. Go ahead and encapsulate, right, that packet into a frame, boom, shoot it out. Okay, that is the low-level technical definition, right, of how that routing process works on a host. Okay, And of course, I use the term host interchangeably because, of course, any layer 3 device is going to do the exact same thing. Okay. Firewall, router, a multi-layer switch that has layer 3 functions. It's going to do the same thing. Okay. So let's take a look at this diagram, right? What's happening, right? We're still on my KVS PC. Now we're not shopping for Christmas trees. Now we're shopping um for Yeezy slides, right? Apparently she loves the Yeezy slides. We're gonna go with that, right? So, but she has to get to the Adidas website, right? So what's gonna happen is, right? She tries to reach out. She reaches out to her router. Her router that gets that, gets that frame in, right? From a layer 2 perspective, it's going to go ahead and get it within her router, right? If we're looking at step 1, let me take my pencil out so you guys can follow along. 1 second. And draw. There we go. Right? Right here, right? It's going to come into her router, right? And from a layer 2 perspective, right? Because this is a layer 3 device, right? It's going to go ahead and take a look. It's going to say, let me go ahead, check the FCS. Let me check the Ethernet header, see, okay, this is for layer 3, this is for IP, right? Cool. I can go ahead and de-encapsulate it and look for the stuff that I'm really looking for, right? Because I'm a device. I am a layer 3 device, right? Layer 3 part of the OSI model. I'm a layer 3 device that is only worried about layer 3. I just need to get to the part that I'm worried about, right? Is what is the source IP address and what is the destination IP address, right? Then when we look at that, right, we're going to go ahead and see, now I know where it needs to be sent. Let me go ahead and engage my RIB, right? RIB meaning routing information base, or routing table to keep it short. Okay. I'm going to say the technical term, and I'm also going to say, of course, the simple term, so you guys start to get use of this technical terminology. Okay. So once my Kivia's routing table says, hey, I know where to send this, I know what interface to send this out of, but I just can't send this out of my interface via layer 3, right? So I need to go ahead and encapsulate it, right? So the router, right? Her router is going to go ahead and encapsulate it using a layer two technology, right? Whether that be one of those old routers that use HDLC or the new routers that have 802.3, right, on it, right? Right, and we'll go ahead. It's smart enough to go ahead and shoot it over. Boom, and it's done, and it has that all set. Okay, this is an in-depth process, right, and a more detailed process to show you guys how the routing process works, right, within a router. Okay, let's keep going. So let me go ahead and clear all this. Any questions, guys? I'm gonna try not to go too fast. If you guys have questions, please stop me. I'm gonna just get a brief moment for questions. Let me know if you guys are good. I'll take the silence as if you guys are good. So let's go ahead and keep going. This just explains everything that I went over. So I'm not going to read to you guys. You guys are functioning adults. So let's keep going, right? So, right, exactly what I explained to you guys, right? What that process is, what's happening on that router, right? Look, and I want you guys to look at the title of the slide, right? Routing step 1, decide whether to process the incoming frame, right? Right? And Nick's router, right? We're going to call this Nick's router, right? Nick's router is going to go ahead and take a look at it and say, does this match my MAC address? It does. Oh, okay, this is meant for me. Perfect. So I need to go ahead and de-encapsulate it, right? I'm sorry, let me not jump ahead. After I see it's meant for me, I need to go ahead and check the trailer, okay? I need to check the trailer of this frame, right? We call it frame because it's at layer 2, and check the FCS, right? The frame check sequence to see, is this frame unchanged? So Nick's router is going to say, am I looking good from a layer 2 standpoint? Did anything happen from the host going through the switch to get to me. Did anything happen to this frame? If not, if it looks good, okay, let's keep rolling. Okay, let's keep rolling, right? So now, right, Nick's router. Nick is shopping for hiking boots in the summer. God knows why, right? Everybody has quirks, right? So, this is what his router is doing, right? Because he's trying to get to the hiking boots website, right? So now he went ahead, he has the frame, but again, he is a layer 3 device, right? He wouldn't know how to forward, right? Forward this frame because he's a layer 3 device. He's not a layer 2 device. So he needs to go ahead and de-encapsulate, take off the parts that don't matter so he can read the parts that matter, right? Which is the IP packet, okay? So, right? So he needs, so he'll go ahead and de-encapsulate that, snatch that off, and take a look at the section where it'll actually match his language, which is IP addresses, right? The source and the destination, okay? So this is what Nick's router is going to do. It's going to de-encapsulate that packet, right? Then, once it de-encapsulates and say, all right, guys, let's go ahead and read this packet, right? It says, oh, okay, I know where I need to send this, right? I know what the destination is, but now let me engage my routing information base, my routing table, and see how do I reach it, okay? So I see that address is 172.16.2.9. Okay. Where do I see that on my routing table? Right. And so what Nick's routing information base routing table is going to do, right? The CPU is going to say, all right, let me look through what matched up. This matches. Okay. And there's no other entry, right? So I know how to get to this network, but how, right? Where do I shoot it out of, right? And so it's going to go ahead and look at this and say, hey, I know where to shoot it out of, right? This is my next hop, right? That is the next IP address that I need to send it to, and to send it out of this interface, right? And that's where his router is choosing where to forward the packet. This is where that decision is happening, right? And two big pieces, right, that are fundamental, and I want you guys to lock in, right? Once a router gets that, or a firewall, right, a layer 3 device gets that packet, right, and it goes to layer 3 to go ahead and take a look at stuff. First, it needs to match the destination network. Then it needs to forward to that destination network. Okay. First, it needs to match. Then it needs to forward. Hey, Makivia, go ahead. I see your question.
Okay, all right, I have a question, and it might be a dumb question. So, like, say if from the land you're trying to get to, like, I don't know, a server or whatever, how do you, and you have the destination IP, which is the server IP, how do you find the gateway to hit that IP, the destination IP? Like, is that what you're explaining now? Or does that question make sense?
No, the question does make sense, right?
Like, how do you find
So,
the gateway IP of a destination? I guess that's my question.
no, that was a great question, right? So within any host, that is something that needs to be set either by admin or dynamically through DHCP, right? There's no way for a host to learn um automatically learn who its gateway is without it being set. Okay, right? And to be more specific, it needs to have the layer 3 portion set, right? Right? We all been in Windows, we all been in Linux, right? We have our IP address, we have our subnet mask, and we have our default gateway that needs to be set, right? That needs to be set on that host. Now, here's the thing that needs to be learned is layer 2, is the MAC address, where to send it. That needs to be learned dynamically, right? And how is that learned dynamically? Through ARP, okay? Through address resolution protocol, right? So my Kiva, your computer is going to say, okay, I have all these things set. Either I learned it dynamically or my Kiva has set these values to be static, right? IP address, subnet mask, and default gateway, I need to know how to talk with the default gateway and see if it exists here by doing an ARP. And I do that ARP, right, that lives at layer 2.5 to say, hey, here's a broadcast via layer 2. Can anybody, whoever is 192.168.1.1, please respond to this message and respond with your MAC address so I can know where to send you so that my host can encapsulate, right? Go from layer 3 and layer 2 and encapsulate this so it can prep and get ready to go ahead and drop it to layer 1 and go ahead and push it out the wire. Does that make sense?
Yes, it does. It does make sense.
Mm-hmm.
But I guess in the scenario of like, I probably am just re-asking my question of like, basically in a live troubleshooting session, like, is the client supposed to know the default gateway of like a VoIP server or something, or like a server on the other end? Like, if the firewall is dropping the LAN traffic that's trying to get to a server,
Mm-hmm.
like, how is that? How are
So,
you?
and we're talking about voice, right?
Yeah.
So, with that, right? Because of course,
Okay, I don't mean to stir it in like this whole.
oh, you're
In,
fine. Oh, you're fine. This is fun. This is fun. This is fun. I need you guys to stir it off course. It's perfectly fine. But
okay.
so with the voice over IP, and it's been a while. It's been a while since I touched it. So my understanding, right? And I do know this part, right? It queries, right? A server, right? Its DHCP settings is different than a regular DHCP. There's different DHCP options that sit on that server.
Okay. That explains it. Okay.
Okay. And so that's going to be set on the host. So it knows the IP addresses. Does it know how to get there is a different story because it needs to be routed. It's going to learn that stuff dynamically, or you can set it manually, more work for you. But if we're going to just go default to the DHCP, sending all that information to maybe that phone, right? That voice over IP phone. It's going to have that. It's going to know how to get to maybe the TFTP server and whatnot. But as far as routing, because that's where it all comes to, it comes down to routing as far as to see if it can reach it or not, right? Maybe it has to go through a firewall, right? And if it has to go through a firewall, does this firewall, can it, let's start first, layer 3, can it reach the subnet to where the server is at, right? And if so, perfect. Next, maybe the higher layers, right? Maybe SIP protocol, maybe these other protocols, maybe RTP. Is that allowed on the firewall policies, the firewall ACLs, to allow traffic to that server, right? Is one interface, one zone, right? One zone from maybe one part of the LAN or one VLAN, is it allowed to reach another LAN or another VLAN? Okay. These are all things you need to take in perspective if you're dealing with the firewall, if you're dealing with the router with ACLs that mitigates traffic, mitigates access to different subnets, different networks. Does that make sense?
Yes, it does. You explained that
Okay.
perfectly. Thank you.
Okay. Okay.
I have a
Go.
question,
Yeah.
David.
Yeah.
All right, so let's just say I have a whatever, let's just say I have a SQL server, right? And
Okay.
let's just say a client is just working on whatever they're working on and pulling from the database. So let's just say that that packet right there,
Uh-huh.
172.116.2.9,
Uh-huh.
when it says it's matching, right? In the routing table,
Uh-huh.
is it just saying, okay, well, this is where it needs to, well, I see that it's part of this subnet. However, in order to get to that subnet, the next hop that you need to reach first is this one right here, which is 172.16.4.2.
Uh-huh.
And then when you get there, then in that routing table, it should have, I guess, another route that would lead you closer to that subnet, which will be 172.16.2.0.
Theoretically, right? You're absolutely right. So theoretically, right?
Okay.
Theoretically, right? If maybe is dynamic routing set up, right, within your topology,
Right.
right? Or is it all static routing? As far as how to
Mm-hmm.
reach it. So that's where you have to say, hey, theoretically, is this set up for proper routing?
I see.
You feel what I mean? Right?
Mm-hmm.
And so, and you asked a good question. How does it know how to, once it has a match, where to send it? Well, let's dive a little bit deeper, right? So how it learns is one statically, right? So the knock, right? You and Mikevia, right? You guys get this request from a customer to say, hey, we have a new network. Of course, I want you guys to go ahead and put this in the routing table, right? In the routing information base. Right? And statically, what would you guys do? You guys are putting the subnet, right? The subnet mask, right? And you guys are putting either A, right? And this is which in your IP route command within global config mode, you guys are either putting that next hop, right? Or the exit interface, okay? Because it can be either or. It can be either or that you set statically. Dynamically, though, it's dynamically learned, right? It's dynamically learned. If I have router 1 and router 2 and router 3, right? If dynamically I can reach router 3's network via router 2, all I'm going to learn dynamically using a routing protocol is, oh, it just needs to get to that network via this next hop, which is router's 2's, IP address. Make sense?
Yes. Yes, it makes sense. So
Okay.
yeah, yes, it makes sense. So either static or they learn dynamically the based on the routing protocol that you enable on the router or whatever yeah, on the router or whatever I guess device that is routing on the network.
Exactly. Exactly.
Okay.
So that's it. That's basically it. So um, that's all you have to remember for now. And moving forward, right? Because we're just touching the fundamentals for now. I told you guys about the routing information base, right? Which is the routing table, right? There's another part of it, right? It's a good segue from Makivia's and Antoine's questions. Is there's also a forwarding information base on a router, okay, or a layer 3 device, okay, whether that be a firewall or what have you. So we'll touch on that in the future, right? For now, information base, routing table, okay. So let's keep going, right? So we already talked about, right, Nick's router. It's choosing where to forward the packet, right, and it knows how to do. It knows where to send it, right? So now, once his router knows where to send it, it says, "All right, guys, this Amazon package is ready to be shipped." Right? What's going to happen, right, is his router is going to say, "All right, let me go ahead and put my layer 2 header and trailer on here, right? Right? I'm going to put my layer 2 header and trailer on there, whether that be whatever, if I'm using an old router, whatever layer 2 technology I have there to send that traffic, right? HDLC with serial ports, or of course nowadays we have Ethernet ports, right? We have gigabit ports and stuff, gigabit Ethernet ports uh, that can work with 802.3. It's going to put that Ethernet frame on there, okay? Add a router, right? That runs at layer 2, okay? So once it encapsulates that into a frame, it's going to go ahead and send it. Then at the last step, once layer 2 is taken care of, it's going to go ahead and shoot that, right? Shoot that on the wire, right? And now we have routing, right? And think of it as, um, think of it as, how do I want to explain this? Think of it as like a router has maybe a cop that's trying to tell people where to go if the stoplights are broken, right? And so, we're at a stoplight, but it's broken. And that cop is going to say, hey, go this way. Wherever you're trying to get to, here, go this way, right? That's what a router is built to do. It's built to route packets to the destination, right? It doesn't worry about the source address, right? There's a couple of technologies we can include. We'll talk about that later, but it's worried about the destination. Oh, cool. I got this packet that's meant for me, right? I already checked layer 2 and all that stuff. Oh, I'm just worried about the destination. Where you want to send it? Perfect. I'm going to go ahead and send it there. Okay. That is mainly, fundamentally, what the router is worried about. Sending packets to the destination. Okay. Now, we're going to take a side step because I think you guys need to understand this so it can all come together, right? And if you guys understand this, I don't care what you guys are trying to learn. BGP, OSPF, eGRIP, ISIS. It'll all make sense, okay? Once you know this fundamental thing. And it is path selection. We're diving into the CCNP realm, but I'm perfectly fine with it because I believe you guys need to know this. So, and I know you guys are all working in the field now. If you guys know this, it'll all make sense with what the router's doing. So, path selection, right? What our router does, it makes decisions, right, on where, and how to send traffic, right? What's its election process, right? How does it choose, what's the best match to take and where to send it, right? So there's three things, right? There's prefix length, there's administrative distance, and there's metrics, right? Right? And in that order, it's going to look at first the prefix length, then the administrative distance, then the metrics, right? So let's go ahead and take a look at it, right? So let's say, right, Antoine is trying to get to, I don't know, right? Maybe something that's in the cloud, right? That has a 10, that has a destination for 10.0.3. Maybe 4, right? And so he's trying to send it, right? He's trying to send it to that host address, right? Now it gets to Mykevia's router, right? Mykevia owns an ISP. It gets there, right? But when it gets there, right, she has a couple of options. Her router has a couple of options, right? And we're talking about the prefix length there. She has different ways, right? Because Mykevia is smart and she sets up redundancy. She has multiple ways on how to get to the destination subnet, right? But let's move out of the subnet and let's move to the subnet mask, right? That's your prefix length, okay? So what that router is going to do, it's going to say, what is my longest prefix length, right? What is closest, how I like to remember it, what is closest to /32, okay? So Antoine's trying to reach Google, right? It comes to Mykevia's router, right? What's going to happen is Mykevia's router is going to say, okay, I know how to get there in 3 ways, right? We have a /24, right? Because the destination is .4. We have a /24. Okay, we can send it out of gigabit /33, right? But, that's not close to /32. I do have a /26 that's close to 32. So that's even better than /24. So no longer is this a consideration to go ahead and send it, right? Right? This is no longer a consideration, okay? Because /26 versus /24, /26 has the longest prefix match, okay? It has the longest prefix length, right? Length meaning it's longer than /24 on that binary, right? Binary scale to get to /32, right? But now, right, if we dive deeper, right, into Mykevia's routing information based on her router, she also has a way to get there, but that's a /28. That's a /28, right? So that prefix length is even longer, right, on that binary scale, and it's closer to 32. So now, what her router does is say, we're not going to use this, and we're not going to use this interface. We are going to send it out of gigabit Ethernet 1/1 because /28, even though the networks, the subnets are the same, that prefix, right? That silent notation, whatever you want to call it, that slash, that number that's behind that slash is a little bit more specific than a /24. Or what's a little bit, it's a little bit more higher than what's lower, right? On the lower end of that binary scale, right? So /28 is going to be a /24. Does that make sense? I know that was a lot.
Yes, it does.
It does?
Yes.
Okay. Any questions, guys?
No.
It's it.
Screen right there.
Only thing I could say, only question, not question, but like, it sounds like the the higher the cider, the I guess the best, that'll be the best resolution
There we
in
go.
terms of the path.
There we go. Right. And
Okay,
you guys have to remember, right? Because you guys are engineers, and the reason why I'm saying all these technical terms, because I want you guys to know, right? I want you guys to actually know what this thing is called, right? Path selection. The first, in that election process of path selection, the first thing it's going to look at is prefix length, right? And I'm going to show you where, where of course you can have a match at this first election, and where we would need to go to that second election type, which is administrative distance. Okay. So let's go ahead and move forward. Any other questions? Okay. All right. So let's keep going. Next, right? So for an example, right? So we're still with Antoine and Makivia, right? So let's say, right, rather than the longest, the prefix lengths, right, they match, right? Let's say she has, right, she's using OSPF, right, within her ISP topology, right? So she knows how to get, right, to that destination with two different interfaces, right? Two or three different ways to get there, right? And the prefix length is the same. Now, when you go ahead and check the AD, right? OSPF looks the same, right? But what if she had another, right? And one of those paths, right? One of those options, right? One of those destinations, if we go back, maybe, right? Maybe the first one is she switched that to be eGrip, right? Now, if she switch it to be eGrip, right? And they're all a /24, the one using eGrip is going to be used versus OSPF. Makivia, why do you think so?
What?
So, my bad. It's all good. It's all good. It's all good. So, right. So, in regards to path selection, right?
Okay.
So we have three routes, right? We have three routes on the table. Let's imagine that all the routes that you have are a /24, right? So we can't use this election process. We can't use a prefix length election process, right? To go ahead and choose where to route this traffic, right? So now we need to go to the second election process, which is administrative distance, right? Your routes, two of your routes you have is an OSPF, right? OSPF route, right? It has an AD of 110. You have one route that's an eGrip, right? ERGRP route, right? To get to the destination network, right? Which one would be selected or installed in the routing table? The OSPF one or the eGrip one?
Would it be the eGrip one because it's a lower administrative distance?
Absolutely.
Okay.
Okay, guys?
I'm listening. Yep.
Okay. So guys, that's it, right? So if Makivia's router says, all right, the prefix length look the same, she set up redundancy, but the prefix look the same, we need to go ahead and check AD, right? Oh, the AD, she has OSPF, right? But then she has eGrip, right? We need to go ahead and use the eGrip because it has a lower administrative distance, right? Even better, right? If my Kivia's coworker, Nick, right, comes in and say, hey, I'm go ahead and set up a static route. Which one is going to be chosen? The static route. It has a lower administrative distance. Okay.
I have a question about static routes before you move on. Sorry.
Okay. No, it's all good.
So, like, okay, when you have multiple static routes, for example, configured on a firewall, and you know how like you set the administrative distance, and then there's an option to select the priority. Is priority after this? Like, when do you like taking an account of priority when it comes to configuring routes? Or is that the same thing as, or do you know like what I'm talking about? Like how there's like administrative, you can set the administrative distance and then also the priority.
So yeah, no. So you're right, and that's the next thing. But it's not
Okay,
called.
sorry.
It's not. No, you're good. No. This is excellent. You guys are doing excellent. So it's not so much called priority.
Okay.
It is called metric.
Oh, okay.
Okay. So if
Oh,
our
okay.
AD, and we'll take a look at this. If our AD maybe is the same, right? Maybe she does
Right.
have, maybe she have multiple ways, right, to get to that network. They're all using eGrip. They all have an AD of 90. She created, because remember, Makivia set up redundancy. Makivia and Nick set up redundancy. So she has multiple ways to get to that destination. Her router is going to say, Jesus Christ. So AD is not going to be a election, right? It's not going to be a good factor to choose where to send it out of, right? What I'm going to do is take a look at that metric, right? That weight of that route. Which one is better? Okay. Which one is better? What am I going to use? Right. And so once it does that, it's going, her route is going to say, hey, this eGroup route has a better metric than maybe the other one, the other, the other routes. Because again, her router is going to prefer the lowest metric, okay, for that administrative distance that is the same all across the board. Okay. Now let me make a point here. Metric isn't going to be used if AD is already caught. What I mean by that, if we have routes learned from OSPF and routes learned from eGrip, maybe a metric in OSPF is low in OSPF standards, and a metric in eGrip is a little bit higher in eGrip standards. That doesn't matter, right? Because from the second election process standpoint, we're just looking at the AD. AD of 90 is better than the AD of 110. So we don't even care about the different metrics within the different routing protocols, right? We're just going to go with the AD. Hey, we're going there, right? And same thing, right? If we go back to the prefix length, right? If the prefix length is more specific for a certain route, right? Maybe we do have all of our routes are, eGrip routes, right? Or OSPF routes, right? But one is more specific than the others. Guess what's being installed in that routing table? The more specific, that /28 is going to be installed versus that /24. Does that make sense?
Yes.
Okay. Okay. All right. Any questions? Okay. And on that note, that's it for part one of routing. Okay. So, guys, we can stop here, right? I can give you guys the option to stop here. And then we can do our lab session next time, right? Because I don't want to throw too much at you guys with the holidays coming up. Or we can go ahead and have this lab session now. You guys can take a 10-minute break because I know this is a lot. You guys can take a 10-minute break, and we can come back and just go over the lab and just see the difference, right? Let me know what you guys want to do.
I'm down to keep going because this is good because this is helping my troubleshooting skills. That's why I'm asking you these questions. So I mean, I'm good to keep going, but I don't know about anyone else.
I'm down
Okay.
because it's like fresh in my mind. So yeah.
Cool.
Right.
Cool. Cool. All right, guys. Well, we'll take a 10-minute break. Let me grab some water. Yeah, let me grab some water. You guys take a little break, and then I'll see you guys back in let's say 10, 12. All right. All right. Let me go ahead.
Cool.
All right, let's restart the recording. All right, guys. So we have our topology. Okay. So we have our source, right? Our source network, which is, or our source device, R1, right? It is trying to reach. It is, let me get my pencil, right? It's trying to reach the destination network, right? 2.2.2/32, right? Host address for the loopback interface on R5. Okay. There's a couple of ways, right, that this topology can reach it, right? Whether it be static, whether it be using egrep, or whether it be using OSPF. Okay. So, right. So we're going to work together on this one. So I'm going to ask you guys questions. I want you guys to answer, right? So if we take a look at this and talking about path selection, right? Nick, which path is R1 going to take to get to the loopback destination network off of R5, and why?
Okay, I would say static.
Why?
I'm basing off from the metrics because it's the lowest number of all.
Is it the metrics?
I want to say yeah.
Okay. So let's review.
Okay.
Right. So remember, 3 election process. We have the prefix length. After that, right? Because the prefix length is the first one. We have the administrative distance. After that, we have metrics. Okay.
Okay.
So we don't skip an election process. We don't just, okay, we're not going to look at prefix length. We're just going to jump straight to metrics. That's not what the router is going to do. Okay. It's going to look at the prefix length. It's going to look at the administrative distance. Then, boom, it's going to look at some other stuff. Okay.
Right on.
All right. So with that being said, let me ask you the question again. Which path is it going to select?
Let's see. EIGRP.
Okay. Why?
Well, first, I'm looking at through the prefix.
Okay.
They're all similar. They're /4.
Okay.
But I notice where I'm focusing on the router that has egrep.
Okay.
On the other side, okay. I kind of want to say it's not similar because that network. I can't pinpoint on that right now.
Okay, we're gonna work through it. So okay. You're on the. I first things first. Yeah. I love your explanation because you were right on the right path, and then you stopped yourself.
Yeah.
Right. So you said you chose. You said the prefix length is the same for the destination. Boom! Yeah. You made me happy, right? Because you got that part.
Yeah.
Now we're going to the second election process, which is AD. You said egrep, right? Why didn't you choose OSPF?
Yeah, I was skipping right there.
Why did you choose OSPF? Tell me. Because again, the election process, now we're looking for the lowest administrative distance.
Yeah.
Why did you not choose? Why did you not choose OSPF? And why did you choose eGRIP?
Yeah, I didn't pay. I forgot about the AD numbers now.
It's okay. I'm gonna help you out. There we go.
Okay.
Right.
Yeah.
And again, we're looking for just like Makivia said, we are looking for the lowest administrative distance.
Right.
So with that being said, if we're looking for the lowest administrative distance,
Okay.
which path is R1 going to take?
Lowest one. Well, if we're talking about the lowest one, then I would go back to static.
There we go. Absolutely.
Okay.
Absolutely.
So would that mean we would take, yeah, because the numbers throw me off for the IP address. Why?
It's okay.
Okay, so now now it chooses that network, that portion, or from that interface of G00, going through static, and then from there, well, I guess it just chooses straight from there.
So the path, so if it's going to use static, right, it's going to go from R1 to R2 to R5 to reach that network, right?
Right, correct.
Okay. Okay. All right, perfect. So let's take a look, right? Let's verify, right? Because of course the motto, trust but verify. Let's get into R1. Let's check its routing information base, and let's take a look to see if that is the case.
Okay.
Okay. To warn you, R1 and R5 are running all three. It has static routes, it has eGRIP configured, and it has OSPF. Let's take a look at, let's go ahead and take a look at the routing table, okay? Okay. So, to reach two dot two dot two dot two, it is going via 6.4.2.2, which of course is R2 address. So Nick, you were absolutely correct.
Oh,
okay.
All right.
But let's take a look at this, right? Right.
Yeah.
We know it's using the static, right?
Right.
But does that mean eGRIP and OSPF doesn't know about how to get there? Let's take a look.
Right.
So, this is just for funsies, right? Let's look at we're going to look at the eGRIP topology table. Okay? We're going to go ahead and take a look at that, right? So the eGRIP topology table, right? What it's going to do, it's going to show me all of the routes that it knows about. Okay?
Okay.
See that, right? So it knows how to get there using eGRIP. Right? And so let me give me 1 second. Let's take a look. That's what I'm looking for in the database. Been a while. Been a while. There we go. Okay.
All right.
Right. So it also knows, right? It knows how to get, OSPF knows how to get to, it knows how to get to it knows how to get to 2.2.2.2. Matter of fact, this doesn't really show. Hold on, let me do this database and summary. Let me nope, that's not what I'm looking for. Give me 1 second, guys. I love using the question mark. And we are looking for, there we go. There we go. Okay. Show RP, OSPF. It's been a while. It's been a while. So we also see that OSPF knows how to get there.
Right.
But our routing table shows the static route. Okay. So the prefix length is the same across all of them, right? So then it reverted to administrative distance. Okay.
Oh, okay.
But what happens? What happens here? Happens if we do this. Oops, putting the wild card match. All right.
Okay.
What's going to happen, right? As far as on how to get to our destination network, which is 2.2.2.2, right? Let's take a look at that. Let's take a look at that routing table now. Okay.
Okay.
So it has the code of D, right? That means if we look at our markers here, right? If we look at our markers here, D means egrip. Okay. And so, of course, that means it's going out of gigabit 0/1, right? That's right over here. Okay. Right? Why did it choose egrip? Why did it choose egrip? Right? Here's why. egrip has a lower administrative distance than OSPF. The prefix is the same, but that has a better one.
Right. Right now.
Okay.
So on AD. Okay. Okay.
Okay. Does that make sense?
That makes sense.
Okay. So we're gonna stop here. I'm gonna keep this lab. I'm not gonna break this lab. We're gonna keep this same lab. I don't want to throw too much at you guys.
Okay.
We're gonna use this same lab because we're not done here. Because what I'm going to do for this next lab is show you guys the difference of the first election one. What if exactly like we were talking about with the Makivia and Tuan example, what if maybe we're all using static routes, right? Right? We're all using static routes for these different paths, but we have different prefix lengths. So we'll see that actually in the lab, and we'll see how that works in our next lab, okay?
Okay, that sounds good.
All right, guys. Well, you guys have a great night and happy Memorial Day.
All right, you guys. Thanks, you too.
Thanks,
Later,
guys.
guys.
Later.